And welcome to review session 15. We are beginning on page 813, figure 21.7, and we're talking now about electrolyte balance. And on page 813, remember then, the two figures give two specific examples of electrolyte balance. And so 21.7, if we assume that the concentration of potassium ions in our blood plasma increases, the adrenal cortex, as a result, secretes aldosterone. The renal tubules then increase the reabsorption of sodium ions, which is what we concentrated on previously when we talked about effect of aldosterone. But notice also then at the same time, this increased secretion of aldosterone increases the secretion of potassium ions, and as a result then potassium is lost in the urine due to this increased tubular secretion, and we've compensated then for the higher plasma potassium ion concentration that triggered this series of reactions. 21.8 then, down at the bottom of page 813, again, another specific example of electrolyte balance. And so we're assuming that plasma calcium ion concentration has decreased. You'll recall then the parathyroid glands react to these decreases, and without going through all of the arrows and all of the various pathways in the figure, if we just go down to the lower left-hand corner, recall that parathyroid hormone causes plasma calcium ion concentration to increase, and so bumps it back up toward normal. On page 815 now, figure 21.9, I'm sorry, 21.9, and here we're getting into talking about acid-base balance, and you'll recall then in this figure, we're looking at various sources of hydrogen ions, what kinds of chemical reactions within the body produce hydrogen ions. And so quickly just running across that top group of, that top line of different types of reactions then. So aerobically breaking down glucose produces an acid. Anaerobic respiration of glucose produces an acid. Incomplete oxidation of fatty acids produces acidic compounds. Oxidation of amino acids, which contain sulfur, produces yet another acid. And finally, breaking down phosphoproteins and breaking down nucleic acids produces yet another acid. And of course, all of these acids, by definition, then will increase the hydrogen ion concentration of the body fluids. On page 817, figure 2110, looking now at the respiratory excretion of carbon dioxide. And so when we exhale more carbon dioxide, when we get rid of more carbon dioxide per unit time, what effect does this have on acids and bases and their concentrations? So running down the figure then, cells in this example produce more carbon dioxide, so more cellular respiration going on, presumably. The CO2, remember, each CO2 molecule can react with an H2O molecule to produce carbonic acid, H2CO3, which by definition, again, releases hydrogen ions, which in turn stimulates the respiratory center, causing an increase in the rate and the depth of breathing, causes more carbon dioxide in turn to be exhaled again, excreted through the lungs. And again, if you're getting rid of carbon dioxide, there are fewer CO2 molecules to combine with water molecules, and so less carbonic acid is going to be produced, and hydrogen ion concentration will go down. On page 818, figure 2111, and looking now at the renal mechanism or a renal mechanism for regulating acid-base balance. And so quickly running through the figure, if upper left-hand corner, our diet is high in proteins. Proteins, remember, are made of amino acids. So we're eating more proteins. We're breaking down more amino acids. The components of those amino acids then are forming a couple of other acids in the body, sulfuric and phosphoric acid. In turn, increased hydrogen ion concentration in the body fluids. And to balance for this then, increased secretion. And remember here we're talking tubular secretion. So increased secretion of hydrogen ions into the renal tubules. And as a result, we're losing more hydrogen ions in urine, and our hydrogen ion concentration in the body fluids is returning to normal. On page 818, on page 818, lower right-hand corner, figure 2113, getting into talking about acidosis and alkalosis. And you'll recall then that acidosis is talking about a condition in which the pH of blood in our arteries is more acidic than 7.35. And alkalosis, on the other hand, is a condition in which the pH, again, of arterial blood is now above 7.45. So normal pH range then of blood in our arteries is 7.35 to 7.45. Again, acidosis, if the pH number goes down, meaning acidity goes up, and alkalosis, if the pH value goes up, remember, meaning that acidity is going down. And then finally, 4 specific types of acidosis and alkalosis, 2 of acidosis, 2 of alkalosis. And so 2115 on page 819. And so here we're talking about respiratory acidosis. Respiratory implying that it has to do with respiration, it has to do with carbon dioxide. And working our way up from where it says respiratory acidosis, this is caused by an accumulation of carbon dioxide, again producing more carbonic acid. And what causes us to accumulate more CO2 in our body? Moving to the upper row of 3 boxes now. If we decrease the rate and depth of breathing, then we're holding on to more CO2 in the body. If there's an obstruction in our air passages, if there's decreased gas exchange, any of these conditions will cause us to accumulate carbon dioxide, and again will lead to respiratory acidosis. Looking at figure 2116, so still talking about acidosis, but now talking about metabolic acidosis. Acidosis produced by chemical reactions that don't involve breathing, that don't involve carbon dioxide. And so 2116, you'll recall we began by looking right at the middle of the figure, that middle box, which says metabolic acidosis. If we work our way up from this box, metabolic acidosis can occur if we accumulate acids. And again, we're talking about non-respiratory acids here. And what can cause us to accumulate these non-respiratory acids? Well, 2 examples would be if the kidneys are not excreting acids as quickly as they should be, or in the case of diabetes, if acidic ketone bodies are being produced, again, leading to accumulation of non-respiratory acids, leading to metabolic acidosis. And then, on the other hand, the lower part of the figure, metabolic acidosis can also be caused by an excess loss of bases. So we can either accumulate acids or we can lose bases. Either of these leads to acidosis. And this excess loss of bases then can be caused by prolonged diarrhea or prolonged vomiting, in each case assuming that we're now losing intestinal contents, which are basic, which are alkaline. And on page 820 then, looking now at 21.7 respiratory alkalosis and 21.17 respiratory alkalosis and 21.18 metabolic alkalosis. So 21.17, again, if we work our way up from the bottom, respiratory alkalosis caused by a decrease in concentration of hydrogen ions, again, alkalosis, becoming more alkaline, becoming less acidic, so a decrease in hydrogen ion concentration due to a decreased concentration of H2CO3, carbonic acid. Why do we have less carbonic acid? Because we've lost more CO2 than normal. Again, this is a respiratory kind of thing, so we're talking about respiratory alkalosis. What causes us to lose excessive carbon dioxide? Hyperventilation. And what can cause hyperventilation? Anxiety, fever, poisoning, and high altitude are among the causes. And so again, if you now work your way back down, all of these four things leading step by step to respiratory alkalosis. And finally now, figure 21.18, so still talking about alkalosis here, but notice talking about metabolic alkalosis. Again, look at the middle box, and there's our metabolic alkalosis. Work your way up to the top. What can cause metabolic alkalosis? If we're losing non-respiratory acids, so things are becoming less acidic, and by definition, less acidic is the same as more basic or more alkaline. What can cause us then, top three boxes, to lose non-respiratory acids? Gastric drainage, vomiting with loss of gastric secretions, so either of these two things causing us to lose the acidic contents of the stomach, and some diuretics, notice, also can have this effect of a loss of non-respiratory acids. And then finally, gain of bases and what can cause this. And one possible cause of gaining bases is taking too high a concentration, too many antacids. Again, if they're antacids, they decrease acidity. Again, another way of saying decrease acidity is saying increase alkalinity. Alkalinity, remember, we're talking about bases, and when we gain bases, then this leads to metabolic alkalosis. So with that, we conclude chapter 21, and with that, we are through the last review session.